Very good morning, girls. How are you? I hope you are doing good, and I hope just give a second, ma. Sorry. Yeah. Okay. So just I'm checking my mic. That's it. So yeah. In the previous class, we discussed that the concept of the zeros of polynomials, and in that we discussed one application also, and now I want to discuss the problems related to this unit 1, and after that I will go for the Muller's method. Okay, so now here clearly we have that the numerical analysis practical papers. In that first method is the first problem is use the bisection method. Already I said how to find the values related to the bisection method, and here the question is f of x is equal to root x minus cos x. Okay, so for this, first of all you have to change your calci into radius, and then you have to follow the procedure. What we have to do, first of all we have to calculate P naught. P naught is 0 plus 1 by 2, that is 1 by 2, 0.5. Okay, and after that simply you have to calculate P1, like by calculating the f of P naught and so on you have to. Okay, so the next one we have that let f of x is equal to 3 of some function is there. Use the bisection method on the following interval to find. So simply they mentioned that different intervals, and they are asking to find P3 only. So up to P3 it is enough. Okay, again third problem also use bisection method to find the solutions accurate to 10 to the power of minus 5. So 10 to the power of minus 5 means simply we have to see that after point we have to take at least 4 digits. Okay, so the next we have that the question is use algebraic manipulation to show that each of the following function has a fixed point. So already I discussed this problem, fourth problem. Next third one, use a fixed point iteration method to determine a solution accurate to within 10 to the power of minus 2 for x power 4 minus 3x square minus 3 equal to 0. So for this one simply x power 4 minus 3x square minus 3 equal to 0 on 1 comma 2, and they mentioned that P naught is equal to 1. For the fixed point iteration, first of all we have to take that x power 4 minus, already I said this one, I gave the hint to you. So here x square minus 3 is equal to 3. Now x square equal to, here we have that from this we took x square common, and next here we can take that 3 by x square minus 3, and x is equal to 3 by x square minus 3 whole to the power of 1 by 2. Like this you can take, and here x is equal to g of x, and substitute that firstly P naught value, the next P1, P2, P3 and so on. Next here we have a sixth problem, use fixed point. This one also we discussed, I gave the hint to you. Use a fixed point iteration method to find an approximation to root 3. So that means x is equal to root 3. Okay, directly they mentioned in a theoretical way, we have to consider it in a problematic way. So that's why x is equal to root 3, x square equal to 3. So x square minus 3 equal to 0. This is nothing but the function. And here what is the asking? Fixed point iteration. So simply you can take that x is equal to root 3. Okay, so now here eighth one, the equation x square minus 10 cos x is equal to 0. Already I said about this one, they gave different P naught values, just we have to actually these are the practical questions ma. So and I'll send, because here we have a lot of, in 8th we have a f bits. That's why here I'll send the problems, which problems you have to write in the record. Okay, the equation for x, some equation they gave, and they asked that use Newton's method to approximate the solution to within 10 to the power of minus 5 with the following values of P naught. Okay, they gave the P naught values, and they are asking to find the some solution, okay, by using the Newton's method. Okay, so the next finally they mentioned that bisection method. They gave one question, they are asking to find the solution in a different methods by using Newton's method, by using bisection, Newton's, secant method, false position, Muller's method. So till we discussed all the 4 except Muller's method. So actually this practical question paper is finished, first unit is finished, but I have to say that one method, that is Muller's method. Okay, now write down Muller's method. Muller's method. Now write down, ma. In that just we have one theorem and statement only, okay, not proof, statement. If z is equal to a plus ib, z equal to a plus ib is a complex zero of multiplicity m of the polynomial p of x with the real coefficients then z bar is equal to a minus ib. Z bar equal to a minus ib is also a zero of multiplicity m, of the polynomial p of x, and x square minus 2ax plus a square plus b square whole power m is a factor of p of x. Okay, so now here next write down, ma. The Muller's method, in the next line, that is just a theorem statement, and now write down. The Muller's method begins by considering p of x is equal to a of x minus p2 whole square plus b of x minus p2 plus c, quadratic equation ax square plus bx plus c, that passes through the p naught comma f of p naught, comma p1 comma f of p1 comma p2 comma f of p2 up to p2 only. Next line, the constant a comma b comma c can be determined from the conditions f of p naught is equal to, what we get here, f of p naught means a of p naught minus p2 whole square plus b of p naught minus p2 plus c, and I am taking it as equation number, this is equation number 1 and this is equation number 2. Next, f of p1 a of p1 minus p2 whole square plus b of p1 minus p2 plus c, equation number 3. Next, f of p2 is equal to a of p2 minus p2 whole square plus b of p2 minus p2 plus c. Then what we get here, 0 plus c, so therefore c is equal to f of p2. Now it is nothing but fourth equation, write down, write as it is. Okay, therefore now what we have that the value of this c is equal to f of pt. Next write down, b equal to p naught minus p2 whole square f of p1 minus f of p2 minus p1 minus p2 whole square into f of p naught minus f of p2 whole divided by, write down, p naught minus p2 into p1 minus p2 into P naught minus P1. Okay, so then next A is equal to P1 minus P2. I will write here, just note down. Okay, so once again see clearly. So generally here we have that P naught, P1, P2, right? So by that only we are calculating f of P naught, f of P1, f of P2. So while we are calculating f of P2, then we are getting that the value of the C. Okay, the next we are taking the formula for the B is equal to P naught minus P2 whole square into f of P1 minus f of P2 minus P1 minus P2 whole square into f of P naught minus f of P2. Okay, so at the denominator value is same, P naught minus P2 into P naught minus P1 into P1 minus P2, right? You can write in any way. So now here just we have that only P1 minus P2, we don't have any square. Okay, so here we are taking this term first and then next this one. So these are the values for the A, B, C. So now after getting the values of the A, B, C, just we have to take that we have to substitute in that formula. Okay, so then next here write down ma, to determine P3, a 0 of P, we apply the quadratic formula, P of x is equal to 0. However, because of round off, error problems caused by the subtraction of nearly equal numbers. Okay, so write in the next line P3 equal to P2 minus 2C whole divided by B plus sine of B into under root of B square minus 4AC. So like this we have to calculate the value of the P3 and P4 and so on. Okay, so now this is nothing but the formula. Actually see the Muller's method is not easy, because here we have to calculate C value, we have to calculate A, B. After getting A and B, again we have to calculate P3. Okay, that means next value. So by taking this one, again here we will get P3. So now here we have to ignore one value and the next again we have to go for the constant value. So like this, to know the P3 or P4 or P5 and so on, we have to calculate 3 values. So it is a very lengthy procedure. So that's why actually in examination no one will, mostly they will not give the problems related to this one, but if they give it is if you have another choice, then ignore it, because it takes more time. Okay, bisection method kanna chala ekku time teeskuntadandi, so that's why. Okay, so now write down one problem. The polynomial f of x is equal to x power 4 minus 3x cube plus x square plus x plus 1, part of whose, okay, that's it. By the polynomial f of x is equal to some value, solved by Muller's method. So here actually they didn't mention any interval. So first of all here we have to check that the interval, okay. So now here just I am putting that 0, then I will get 1, okay. So then next value some 1, then what we get, f of 0 will be 1 which is greater than 0, and f of 1 is nothing but 1 minus 3 plus 1 plus 1 plus 1. So 3 and 3 will be cancelled, again here we have that 1 only, right. 1 minus 3 plus 1 plus 1 plus 1. So again I have that 1 which is greater than 0, and if I put a 0 then I have that it is nothing but 1, and if I substitute some value, so actually here now what I am doing is by substituting the values of the x we get that the value of the f of x, no. So where I am substituting that x equal to 0, I am getting that f of x is equal to 1. Next simply here if I substitute 2, so then obviously what we get, 2 power 4, so 2 2s are 4, 4 2s are 8, 16 minus 8 into 3 24 plus 4 plus 2 plus 1, okay. 16 plus 4 20, 22, 23, 23 minus 24, so here we are getting that it is nothing but minus 1. So directly we can take that the interval is 1 comma 2, otherwise you can take that 0 comma 2, or you can take that 0 comma 1 also, because they didn't mention. So here by choosing a small interval it is somewhat easy to calculate the values, okay. So now here write down, here they didn't give the interval. By taking x equal to 0, x equal to 0 and x equal to 1, we'll get that f of x is equal to 1. Then the interval is 0 comma 1. So here clearly we have that p naught value, that means 0 plus 1 by 2, this is 1 by 2 is equal to 0.5. So I have that clearly p naught is equal to 0.5. Actually it is nothing but what is this equation? This equation is said to be like polynomial equation, right? And if you apply the value, simply you will get one type of parabola, just up downs and again downs. So you will get like this. So you will get like this. So that's why here it is a parabola. There is a chance to get that the negative values also. So that's why here, and here mainly I have to take that the values of the P0, P1 and P2, right? So that's why here I am choosing that the value of the P1. So P0 is 0.5. So next P1 is nothing but minus 0.5, and I am taking the between value, that is nothing but P2 equal to 0. So now here P0 equal to 0.5, then f of P0 is equal to 0.5 whole to the power of 4 minus 3 into 0.5 whole cube plus 0.5 whole square plus 0.5 plus 1, okay. So the next here I will calculate this one. Next P1 is equal to minus 0.5, then f of minus 0.5. The next in the same way P2 is equal to, P2 value is 0. So then finally we will get that f of P2 which is equal to 0 is nothing but f of 0 is equal to 1, okay. So now I will calculate by using calci. Okay, so now here 0.5 whole power 4, 0.0625. What I am doing is, already we know that minus 0.5 whole to the power of 4 minus 3 into 0.5 minus 0.5 whole cube plus minus 0.5 whole square minus 0.5 plus 1. Okay, so here also we will get that same value positive, no? So next here 0.5 whole cube 0.125 into 3 0.375. Here minus 0.5 whole cube into minus 3, so plus 0.375. Next 0.5 whole square 0.5 whole square 0.25 plus 0.5 plus 1, and here plus 0.25 minus 0.5 plus 1. Now just I am adding all this 0.0625 minus 0.0375 plus 0.25 plus 0.5 plus 1. So it is 1.775. Next here this value 0.0625 plus 0.375 plus 0.25 minus 0.5 plus 1 equal to 1.1875. Okay, so now here f of 0 is equal to 1, and we have to consider this value is equal to some c. Now I have to calculate b value. So already here I have a formula, so that's why here simply I am taking that formula and I am going to substitute all the values in that. So now here b is equal to p naught minus p1. P naught value is, what is p naught? 0.5 minus 0 whole square of f of p1. F of p1 means 1.1875 minus f of p2 0. No, it is 1 functional value minus p1 minus p2 whole square. P1 is 1.1875 minus p2, that is 0 whole square of f of p naught 1.775 minus f of p2 value is 1. So now 1 whole divided by p naught minus p2, that is 0.5 into the next p1 minus p2. So minus 0.5 into p naught minus p1, so 0.5 plus 0.5. Okay, so now here it is 0.5 whole square 0.25 into, here we have that 1.1875 minus 1, that is simply it is 0.1875 minus 1.1875 whole square. So it is 1.41015 I have, so 4102 I am taking, and into minus 1, so it is 0.775 whole divided by 0.5 whole square into, and here it is minus. Okay, so minus 0.25 and here 0.5 plus 0.5 1, so into 1. So directly here we have to take that 0.25 into 0.1875. Okay, so it is 0.046875 minus 0.775 into 4102. Okay, this is 1.092905 by minus 0.25. Okay, so from this we have to subtract this value, so 0.046875 minus 1.092905. Okay, so equal to the whole divided by 0.25. So simply here it is 4.18412. This is the value of the B. Okay, therefore what we have, B is equal to 4.18412. So next what we have, I am writing here. So A we don't know, B value is 4.18412. So simply I am taking that 4. C is nothing but 1. Next we have to calculate A value. So now what is the A value? A formula. A formula is nothing but P1 minus P2 P1 minus P2 into f of P0 minus f of P2 minus P0 minus P2 of f of P1 minus f of P2. Denominator will be same. Okay. So now here simply what we have to do, again we have to take the calci. Now P1 minus P2 directly I am taking P1, that is minus 0.5 minus P2. Minus P2 means 0. So it is nothing but minus 0.5 of f of P0 1.775 minus 1. So it is 0.775 because this value minus 1. Okay. Next minus P0 minus P2. P0 is 0.5 into f of P1 minus f of P2. So it is 0.1875 whole divided by, actually in the denominator we have some value, just write it. Otherwise, okay, P0 minus P2. P0 minus P2 means 0.5 minus this one. So actually here we are getting that, 0.5 and P1 minus P2. So minus 0.5. So minus into minus, plus into minus, minus 0.25 into P0 minus P1. So it is nothing but minus 0.25. So now here directly 0.5 into 0.775 minus 0.3875 minus 0.5 into 0.1875 0.09375 by minus 0.25. Okay. So now here 0.09375 and this one 0.3875 minus 0.48125 by minus 0.25 divided by 0.25. Then we have that 1.925. So therefore A value is 1.925. Now what we have to calculate? We have to calculate P3 value. How we have to calculate P3 here? We have to use the formula for that. What is the formula? P3 is equal to P2 minus 2C by minus B plus sine of B into B square minus 4AC, right? This is the formula. Already I gave, just once I want to check it. So P2 minus 2C by B, it is B plus, not minus B, B plus sine of B into under root of B square minus 4AC. Okay. So now here P2, what is P2? 0 minus 2 into 1 by B value is 4.184 plus sine of B is, what is the sine of B? Positive. So plus into plus plus under root of B square. B square means 4.184 into 4 point, otherwise square directly. 17.506 minus 4A 1.925 into 1. Okay. So now it is nothing but minus 2 by 4.184 plus here this value 17 point, directly I am calculating 506 minus 4 into 1.925. under root of 9.806. Okay. So now minus 2 by 4.184 plus, in your calci you have that root button, like this you have one button, just press that one and open bracket, 9.806 close bracket, 3.13145. so I am taking that 1453 I have, so I am taking that one, that's it, 3 decimals. Okay. So now here, which is equal to minus 2 by 4.184 plus 3.131, 7.315, and now here, of course here, yes, that's it, b square minus 4ac. Okay. So now here we will get that only positive. Okay. 2 divided by 7.375. So we will get that minus 0.27118644. So simply 8 I am taking, otherwise 9, 86 no. So here we have that the value is nothing but simply, wait ma. So now here, so this is nothing but P3 value. So now here actually P3, it can be written as a plus IB form, otherwise we can write it as a directly like a P3 value also, but here we have that the P3 value in terms of the i's and so on, imaginary. So once I want to check the values, P0 is equal to 0.5, yes, correct. So A and B. That's it ma. This is the value of the P3, and next you have to calculate the next values, those are nothing but, write down, just I will give like this, we have to calculate P4, P5, P6 and so on, but every time we have to change the value. So now here I took that P0, P1, P2. So for these P0, P1, P2, just you have to calculate P3, P4, P5 and so on. Okay. So now here already what we have, P3 value. Now just substitute this P3 in the functional value. And here in the functional value we are taking that one is positive, one is negative and 0, right. So now by that we have the functional values all are nothing but the positives only. Okay. So don't think about that the functional values will get in terms of get as a one is positive and another one is negative, we will not get like that in the method of the Muller's. Okay. So next you have to change the value of the P0, write down next iteration, P0 equal to 0.5, P1 equal to 1, P2 equal to 1.5, just I am taking that minus 0.5, 0.5, 0, just from 0.5 to 0 minus 0.5 and plus 0.5. Next also same thing, P0 equal to 0.5, P1 equal to 1, P2 equal to 1.5. Length should be, we have to, okay, like in the interval 0, 1 the length is nothing but 0.5. So like that we have to consider. Okay. So we will see in the next class some more applications. Okay. Thank you everyone.